Well, hey, everybody. Thank you so much for coming to my talk. Today, I'm going to be talking about developer experience and why developer experience is crucial to your financial services transformation. So a little bit about me before we get started. I'm Ravi Lachhman. I'm the field CTO at Shipa. I've never gotten anything right the first time. The older I've gotten, if I get something right the first time, it's clearly wrong. I know that. And also trial and error makes software. Now, a little bit about my background. Previous firms I worked at were Harness, Business for Red Hat, and Deloitte. I spent actually a good chunk of my career at Deloitte working in financial services firms. And so this really hits close to home. It might be a little bit of me just venting a little bit about my experience, but hey, learn from my mistakes and let's learn how to make things better. So what are we going to be talking about today? So we're going to be talking about rising developer complexity. Everyone knows that complexity never goes away, but from a software engineering perspective, this whole shift left notion, there's lots more for us to do as a software engineer. All about developer experience, aka DX. What is developer experience and why is this crucial to any sort of transformation? And then also, how do you abstract developer experience? So I'm introducing a new concept here called AAC, or application as code. So let's go ahead and just dive right into it. So developer fatigue and complexity. Have you ever heard this before? Just figure it out. Now, depending on if you're receiving the just figuring it out or just telling someone to just figure it out, there's two sides to the table, right? But with decision fatigue, developer fatigue, how do we start dealing with all this complexity and how do we get here? So let me go through a little journey here about myself. And this is very prudent to my experience. So when I first came out of university and had to build software, as a software engineer, I focused on the Java stack primarily, so J2E and JE. So my primary deliverable was some sort of archive. I had written some Java, wrote some JMS for the event-driven stuff, and I kind of went to one of three target platforms, right? So it could be WebSphere, WebLogic, or Motion, not JBoss. And that's it, right? Like, my entire purview of the world was this artifact. And this artifact, if once it had to go into upper environments, was deployed by somebody else, a middleware engineer who was more sophisticated in the environment than I was. But that was it. I had a very minute or very laser focus on building the feature. Now, if you take a look at what we're responsible for today, right, there's a lot more icons here, but I'm the same person. I'm less hair and grayer and bigger in size, but same Ravi's here that my responsibility has increased a good bit, right? So not only there's more granularity in the language, there's so much that we have to deal with, from open source to we have to automate the build here with Mr. Jenkins, or lay down infrastructure with Terraform. We have to package it. Okay, we package it in Docker. We deploy Kubernetes. Not only that's adding complexity, we have to make some sort of configuration management with Customize, or package it with Helm, and then we have to wire in Fluenty and Statsy and Prometheus for the metrics and observability stack, and then we're going to AWS, right? So there's a lot more that we have to deal with as engineers, specifically software engineers. And so who owns everything, right? It could be one of many people who own this. Is it a system engineer who owns part of that process or all the process? Is it the developer? Right? This motion of shifting left towards the developer, like, does the developer own that entire stack? Is it the DevOps engineer? Is it the DevOps team or platform engineering team that owns a lot of that perspective? Or the more and more, as we mature in the market, the wanted on the milk carton, is it a release? Do you have a middleware or release engineer who's still on the team? Might be, would be very rare if you still do. If you're working in an organization that has one, time might be coming for that person, to kind of automating their job. But let's kind of take another more intrinsic look, right? So who would you rather, this is poised to a software engineer, right? So who would you rather work for as an engineer or a software engineer? Would you rather work for a FANG company, so that Facebook, Apple, Amazon, Netflix, Google, or would you rather work for a bulge bracket bank? Now, I worked, as one of my customers for over a couple of years with one of these bulge bracket banks, so kind of really embedded in that team. And to each their own, right? Each has pros and cons to working with them. But as a software engineer, typically this might run through your head, right? Like, hey, who would you rather work for? Well, looking at FANG, clearly they have the best engineering platforms. They iterate frequently. There's motions on very modern software development paradigms such as GitOps or AIOps, and they're typically on the edge of their technology stack. Versus, if you work for a financial institution or this bulge bracket type of bank, the largest investment banks out there, you're under a lot of regulation, right? Like Dodd-Frank or PIC. There's dozens of regulations you're under, but also you're getting a lot of great domain knowledge. and safety, 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 right? You can't, go fast and break things. You'll crush the financial markets, put the economy to a halt. And who is this dog guy anyway, right? Like if you're unfamiliar with all these regulations, why is Ravi coming here talking about something called Dodd-Frank? But if you just take a lot of that away, if you were to distill the differences between these two organizations, a lot of that would boil down to developer experience, right? There's a little bit of a stigma around financial institutions having poor developer experience, maybe because you don't iterate enough, or they don't release enough, but there's reasons for that, right? And so let's kind of, as a software engineer, let's boil down. Well, first of all, what is DX? Like, what is developer experience? A hint is like user experience, so just keep that in mind. And why is this so influential and important? So I'll give you a textbook definition of developer experience, right? So it's basically the overall feeling and interaction that your developers have when working towards a goal, right? And so, hey, my goal is to create a feature, or my goal is to make something more robust, or my goal is to make something improve upon something. It's very similar and tied to user experience, right? But the primary persona that you're looking at is a software engineer. And so it's basically, what is their experience when they interact with your product or systems, right? And so it's the kind of four main perceptions. It's going to be utility, ease of use, efficiency, and one more that's on here is credibility, like how credible the system is. And so let's actually dig into each one of these pillars a little bit and just talk about, hey, if you were a platform engineering leader or a DevOps leader or system engineering leader at a financial institution, don't forget about your internal customers, right? So having a developer platform or IDP, an internal developer platform, is quite critical. And you probably have one, you made one or strung one together unknown to you. And let's talk about those pillars of DX now. So the first one is usability, right? So these mimic UX design patterns, but let's talk about them in terms of developer experience. So the first thing is usability. Usability is how easy is your software to use and learn, right? So the main question here is to ask yourself is that, like, first-time user of your platform, are they able to accomplish your goals? And so this might be, hey, you know what? I need to deploy I need to deploy the feature that I've just written. Now I have to run through 16 different, ServiceNow and Jira tickets, and I have to, deal with a complicated deployment system, and I have to package things in a certain manifest and decorate things and get them in a format that, the bank will like to have. Will someone be able to do it the first time you ever try it, or they have to have like a more senior engineer and several other team members kind of guiding them through, right? And measuring this can be a little bit challenging because everyone's very opinionated. If someone's been working there for 10 years, clearly they know how to get stuff done, but does that translate into other teams or other departments in your organization? So usability is quite critical, especially as people change jobs. Like the amount of ramp time that a new engineer has, it boils down to usability of the system. Second is findability, right? So it's getting a little bit more granular now. So how quick, this is a core UX problem here. How quickly can a user find a solution or functionality they're looking for in your platform, right? So I might want to roll back an deployment, or I might want to, change some sort of rule set, like, hey, my application needs these ports open and be accessible by these services. Yeah, that's it, right? Like, am I able to find that functionality in the platform? Am I writing something externally? Am I, again, now I have to look for external packaging to do this. So I have to get other teams involved. How quickly can you find what you're looking for, right? And, you can kind of tell that people are struggling in certain areas, or, your deployment times kind of linger. And I like this a lot, credibility. Do the users trust your software to solve their problems? And credibility is a long-term thing, right? It takes a long time to build credibility, and it's very quick to lose it. Clearly, in a consumer market here, like, who would you rather get your music from? The virus machine known as LimeWire or Spotify, right? Clearly use Spotify now. I used to use LimeWire, 15, 20 years ago. But, it boils back to how credible it is. I trust Spotify to deliver me music versus LimeWire, I trust them to deliver me a virus on my machine. But for developer experience, hey, having your service that is consistent and reliable is very critical. And basically, it boils down to this, right? So it's all about these type of metrics. Why are you investing so much into developer experience? There's these four metrics from Dora, the DevOps Research and Assessment Organization, and it boils down to these four things, right? So deployment frequency, how often can you deploy to prod, right? This is measurement of software engineering and development teams. Lead time to change. And so going from code to production, how much time do you need after you commit to code to something getting into prod, right? So if it's a complex process, the lead time increases. time to restore if there was something wrong. How quickly can you get the service back to a usable state? And then change failure rate being, hey, you know what, we all make mistakes, but the percent of deployments to production that fail, right? So having better developer experience allows you to iterate more and also have better metrics in all of these particular categories. And so let's kind of take a little bit of a swivel. How certain platforms have developed, right? And so let's talk about the march to application as code. So going back from static days to infrastructure as code and finally into application as code. And we can kind of see where some investments were made before and then kind of a changing of the paradigm. So this was, given 10 years ago, I was working for a large financial institution or during one of my clients, and I'm pretty sure they're a little bit different than this today, but they're not terribly different. As a developer or as an application manager, our stuff in dev was static, right? So we had our own Jenkins instance, we had our own JBoss instance, we had our own Artifactory instance, and they're all running on static VMs. And so as we kind of climb that ladder to production or go down the journey, we would have to pre-provision these or get them pre-provisioned. So this is going joke is, the long lead times, right? So this might be a little bit rudimentary depending where you're coming from, but these were the times that it took a decade ago, right? So it took a couple of weeks to do some changes. For some odd reason, the networking changes always took forever, and the middleware people were on the ball. And who did this? 3 separate people did this, right? So just keep that in mind. Three teams of people had to make these changes and provision things for you. Now with infrastructure as code, so we're kind of getting into the mid 2010s here now. Like IACs became pretty popular, right? So your Ansibles, your Chefs, your Puppets, your Terraforms of the world. They're fairly commonplace and fairly popular, right? And they're really solving for an infrastructure use case, right? So if we look at these times that we had before, things take weeks and weeks and weeks to kind of accomplish. It's that, IAC brought about 3 key benefits here, right? And so infrastructure as code has a good experience for the operator, right? So IAC is repeatable. No matter what, the process is repeatable. You call your Terraform TF or Terraform apply, it will apply the same way over and over and over again. But by being repeatable, it's also consistent. So you can expect consistency in results. And then also now it's callable, right? So your ISC solutions are part of your CI/CD pipeline, right? So as part of your new feature deployment, it's commonplace to lay infrastructure down at deployment time instead of weeks in advance. Because now if infrastructure is available, we've really cut these particular times down, right? So getting a new VM, given if it's available, you can have one in less than 10 minutes, load balancer changes in minutes, new application server nodes, imagine just the blank node itself. You can have root or vanilla images of all these in a few minutes, right? So that is fantastic. But going back to, if you take it way back to from a couple icons to multiple icons, how our roles are changing here, is that there's a changing of roles now in software delivery, right? So instead of me being very laser focused on the feature itself, which is my bread and butter, there's this new adage called being a full lifecycle developer, right? So, that those FANG employers, darn them, they've kind of, especially Netflix and Amazon, have led the way that if you write the service, you run the service, you operate what you build, right? And so as a full lifecycle developer, I clearly I have the most knowledge because I wrote the service, so I should know how to operate it. You can hear the sarcasm in my voice there. Versus, the system engineer. This is the picture of our VP of engineering. This is Vivek, my buddy Vivek here. Is that, Vivek's like, if he was a system engineer or kind of now he's turning into a platform engineer, that his team or that job function is making sure that the platforms that I deploy to and resources I need have capacity and uptime. And also there's tooling to onboard and offboard my applications or assets onto the platform, right? So that's kind of the changing role. There's this other thing that came about, kind of swung on the scene and, to the public in 2014. It's odd to say that Kubernetes has been out for that long, but now there's Kubernetes, right? And Kubernetes has been around for several years. A lot of the banking sectors have been adopting Kubernetes in certain pockets, some more than others. But basically, Kubernetes has done something that other technologies have not done as successfully before. It's that really Kubernetes is a great equalizer, right? So no matter if you're on the development team or the operations team, or even anybody in between, or even the application infrastructure team, You can clearly define application infrastructure operational steps kind of here in Kubernetes, right? So Kubernetes is declarative. And kind of the main piece here to take back, if you're unfamiliar with Kubernetes or you're just kind of on the fence, is that from a developer perspective, there is code where code was not before, right? And so instead of using F5 or having to lay down particular pieces of infrastructure or making load balancer changes in your IAC, now there's tooling like a service mesh, right? So something like Istio, which is in Kubernetes or can be deployed in Kubernetes, that I'm creating all the rules, right? So not only I don't have to hand a Terraform file the changes or have that network admin vet it. It is basically me writing YAML to replace that configuration. And it's pretty instant, right? So instead of me, I have the power as a software engineer, as the author, I have the power to execute, if that's the way you set it up. And so, but what is missing here, right? And so there's still a little bit, of a disconnect between, IAC and going to Kubernetes, right? And you might say, well, we solve all that. Our development teams, package everything and Helm and customize. And, we just basically have like 60 Kubernetes manifests that we have to deploy. And the dev team takes care of that. And as an operations team, I'm role playing here as again. They, just up to the dev team, use it or lose it, right? But there's stuff that is missing, right? And it's kind of awkward to say and kind of admit it. The first starting from the bottom there, it's a Kubernetes is an implementation detail, right? Like as a software engineer, I might not, or I usually don't care that my deployments are going to Kubernetes. That's how the software is run, but it's not prudent to the feature. I might make some certain design considerations, hey, I'll try to make as much stateless or kind of using some sort of framework to make stuff more resilient than that's more better alluded to Kubernetes and other frameworks. But that's basically it, right? I clearly know that the traffic comes in and traffic goes out. That's egress as an application. But I'm not a networking expert, right? Like me authoring a lengthy Istio manifest, it's beyond me. It's a non-functional requirement to the application. And I assume I wrote a compliant feature, right? Like, hey, it met our code standards. It met our path Sonar Cube. I got a B-, which are the best I've ever gotten in Sonar Cube. But getting to it, I wrote I'm compliant, and I'm not a kernel engineer. Like a lot of these internals. Kubernetes looks a lot like being a kernel engineer versus the platform engineering use case here. The platform engineers have to keep so much running now. Like, okay, it's not only that we have Kubernetes, but we have to have a CI/CD or CD pipeline like Argo, or using a GitOps system like Flux. You have to you have rules-based approaches with OPA. You're scanning your containers with Claire. You're managing all your clusters with Rancher, and you have a fairly large Prometheus deployment, to suffice these applications. But that's what's missing, right? There's a lot of tooling that has to support this. And do I have to learn that tooling as software engineer? Or if I'm writing compliant things or archetyped or templated out things, does that make sense, right? And this is where AAC kind of steps in. So application as code. So it's exactly what developers need, right? And so software is all about patterns, right? And so one of the great things about being a software engineer is that there's a lot of reuse in our work. Now, the domain, the features, there's a lot of innovation that goes on, but kind of like drawing from a standard toolkit of ways to solve problems, there are a lot of patterns we can look at. There's two of my favorite books here. Here's the Gang of Four book about Java, about object-oriented programming. And also one of my other favorite books is EIP Patterns, right? By Greg Hope and Bobby Wolf. It just kind of dictates, hey, these are common reusable patterns that you can have. These are kind of certain approaches that are language agnostic. That you can take, but really teaches you how to think about connecting things together and like what is actually needed, and without giving you a forceful concrete implementation. Kind of looking at AAC, application as code here. So AAC is a concept that we've been working on for a while here at Shipa. AAC is developer experience as code, right? So that's kind of a double entente there. But really, going back to everything that both of us, remember the developer and the platform engineer would need, that, hey, you want a way to define and enforce policies so the author can be the enforcer, or vice versa, or providing a good template. Really talking about in terms of applications, right? Like, hey, our application is XYZ. Our application, I'm not going to dig in too much about Shipa currently, but like, hey, our application has this ingress. This egress has to be a security scan. Also, just obfuscating the infrastructure, right? So as a software engineer, if you choose to go to EC2, sure. If you choose to go to Kubernetes, sure. Like I should be able to run my application somewhere standard. Also getting reporting and support metrics back. They're also critical. And so just kind of, not spending too much time with this, like, hey, the Shipa application as code implementation is that basically this. Both of your platform engineering teams, or DevOps engineers and developers can interact with a standard definition for your policies and the standard definition to your applications that basically plug into any sort of stack that you have, right? And so that's something that we can always take offline and talk about more. One other thing I want to talk about today is, hey, you know what? If you're wanting to take a look at AHC, we have an open source project called Catch, right? So Catch is a policy engine and a standard way of deploying your applications and packaging your applications. And so if you're curious about, hey, what can application as code do for your organization, or how can it improve developer experience? This is actually using Shipa Cloud, or Catch is a great way of taking a look at it. It's open source. We submitted it to the CNCF for Sandbox project. And so we really believe that AAC is kind of like the next evolution of IAC. But with that, that's all I had today. Would love to connect and learn more. I can bore you to death more about developer experience, but be respectful to my peers here at the time of the conference. So you can head to Shipa.io or tweet at me at Ravi Lach, rlach@Shipa.io. And feel free to join us on Slack here at Shipa. With that, hope you enjoy the rest of the conference. Cheers, Ravi.